Hello everyone, my name is Syed Zair Hussain Jafri. I have an assignment in which my task is to explain a machine learning algorithm named as K-means clustering. I will try to explain it as simple as possible. So let's begin. Let me just open this document. K-means clustering. What is K-means clustering? It is an algorithm which helps to learn the groups or categories of the data which is not predefined or labeled before. Um, Let me give an example. For example, there's a data set with employee names and their salaries. That data doesn't tell me that there can be groups formed on the basis of the salaries or on the basis of certain similarities in that group, in that data set. So for example, there can be a group with the employees with salaries more than 50,000. There can be a group with less than 50,000. So this grouping technique is known as k-means clustering. uh, so what are the steps to achieve this grouping technique? The first step is the method involves making clusters and choosing their respective centroids. The cluster. What is a cluster? Uh, a cluster is a group of data points which are similar to each other in certain ways. Um, as I've mentioned earlier, there can be a group with certain similarities, so that group is known as a cluster. What are centroids? Centroids are the data points that are initially chosen randomly, but during the algorithm, it may change. It will change. It may change, and I'll show you that in the code later. So the second step. What is the second step? After assigning cluster centroids, we assign each data point to the cluster which is closer to it. So we have two clusters, for example, and we'll assign two centroids for it, and we'll put all the data values closer to those centroids in those clusters. Uh, the distance between the observing data point and the cluster centroid is calculated by the distance formula, or we can use the Euclidean distance formula as well for data points with the coordinates more than one. For example, two coordinates x or y, or z, or maybe more. What is the third step? When the data points are assigned into their respective clusters, respective groups, we now update the cluster centroids by taking the average of the data points in each cluster. Now the centroid which I said it will change, it may change, will be updated by taking the average of data points in each cluster list. The fourth and the last step is the process repeats until the centroid of each cluster is stabilized, uh, which means that it is not changed or updated it is not changed in the third step. So these are the steps, and now I have written this algorithm in Jupyter Notebook in a code, so let's take a look at that. uh, First of all, I have imported all the necessary libraries, pandas for reading the data from CSV file, numpy for to perform mathematical or statistical operations on the data, and lastly the matplotlib.pyplot splt to visualize our data sets. Next, moving on, I have stored the data set in a variable x. Here is x, and displayed the unclustered data which is present in data.csv in a tabular form and in a graph form as well. I have plotted the points of the data points in the graph with blue color markers here, and after that, now coming on to our second step, I will assign centroids randomly. Either they can be from the data set or they can be totally random. It doesn't matter because these centroids will change after. So now I'm assigning two centroids, centroid 1 4, centroid 2, centroid 2 is 321, and I'll just plot these centroids separately with yellow color markers here. So this is the unclustered data, by the way, because it is not made in groups yet. I have just assigned two centroids here. Now as you can see from the data that this area can be in this group. related to this centroid, or this area can be in this group related to this centroid. And as you know, the centroid will change, so the with each iteration of the code here, we will have a well defined data group, well defined clusters of our data set. So moving on, now I'll just make two empty clusters. By the way, this the k in the k-means clustering is called the number of clusters, is known as the number of clusters you want to make in that data set, particular data set. So I have two empty clusters here, empty lists here, and a temporary two temporary variables, temp c1, temp c2. So now I will write a loop which will execute the second and third step of our algorithm, which is this: assigning clusters to the centroids, assigning data points to the clusters, and updating them. So while centroid 1 is not equal to the temporary variable, the temporary centroid, I'll explain that in a bit. While it is not equal, just run the loop. Sum is equal to 0, cluster 1 is empty, cluster 2 is empty. I'll explain this bit a bit later. And let me just explain from this for loop here. For v in x data, this will iterate for each for every data, for every element in the data x in x. So mm, let me just so yes, uh, now I'll find, as we have the data point in this v now, it will iterate for every data point in this x data set. We'll find the distances d1 with respect to centroid 1 and d2 with respect to centroid 2. And after that, if the distance is negative, we don't want that, we just multiply it by -1 and make it positive. So uh, that's it. And after the distances are calculated, now we'll just group the data, uh, we'll just assign that data point on the basis of the distance. If the distance is closer to a centroid, the data point will move to that particular centroid. For that, I have these conditions here. Firstly, I'll just explain this one, not this one. If the distance 1 is less than the distance 2, simply just the data goes into the cluster 1 list, else it goes into the cluster 2 list. But if the both the distances are equal, so if the both distances are equal, we'll just put that data in the cluster which has less elements in it. As you can see, I've written that in this chunk of code here. So after we have filled our clusters with the data points from the data set, now we'll just update the centroids by taking the average of particular uh, clusters. So for that, for k in cluster 1, this will iterate for every value in cluster 1. I'm just finding a normal average here. This is not anything complicated, this is just me finding average. So sum is equal to sum plus k, sum is here, and sum is equal to sum plus k. And if the length is if the length of the list is more than 0, is not equal to 0, then we'll just divide the sum by the length of that cluster. Else, obviously, if it is 0, the length is 0, then the cluster, then the centroid will be 0 as well. We'll do that for the second cluster as well. So after that, after which we have updated our clusters, centroids and stored them into the temporary centroids here, we'll check if the temporary centroid is equal to the normal centroid, then we'll just break the loop, we'll not run it again. And if it is not equal, we'll just run that code again and update our centroid value and make sure that it is getting equal close to this, and when it gets equal to this, the loop breaks. So let me just run that from the start. Ah, this is normal centroid C1, C2, 4, and 321, which we uh, assign randomly up here. These are the temporary centroids. When they are equal, I have printed them, and when they are equal, as you can see, they are equal, then the loop is terminated. So after this, I'll just print the clusters. As you can see, the clusters are formed, the data is grouped into particular clusters, and now I'll just plot these clusters, cluster 1 with the orange markers here and cluster 2 with yellow markers here. That's it for the algorithm. K-means clustering is done. Thank you so much. Please like this video because I will get marks from it, and I hope you understood the concept of K-means clustering. Thank you so much.